Custom Link just did. This is talking about our app that I work on, the Investigator. And so what does Investigator do? It basically collates all the information about an investigation or a case. So in here we collect all of the case notes, all the pieces of information that have been reported to a police or a police-like agency, and we keep track of all the tasking that they've been wanting to do. So this is, in police terms, what they would call their running sheet. So it's where they had an old manila folder and somebody would come in, they'd just talk to somebody and written some notes, and they'd put it in the manila folder, and the case officer would just give it a unique number, and then over time they'd build up this big manila folder sitting in a filing cabinet gathering dust because the investigation's stalled. So this is just a way of electronically recording all that information in a way that's familiar to the police users. It also collates all the entities that are involved in the case, and by entities I'm talking about people, vehicles, locations, phone number or contact numbers, all those sorts of things that form part of an investigation. And so here we've got an example of a person where they've loaded a photo of them, and there's various types of entities. So these entities are real world, they're things that you can physically hold normally, although there are electronic documents. We also deal with tasking. So the officer in charge, or OIC, for a case might task one of his detectives to go and interview somebody. So I'm not sure if you can read it, but he's put in 2 task results for this task. The first one's to say that he's arranged to interview the witness, and then the next task result is that he's actually completed the interview and he's typed up the results of that interview. So it's really important for the officer in charge or whoever's tasking that person to get information as it's happening. Otherwise he goes, oh, I wonder if he's done anything about it yet. So we had this concept of interim tasks and then a final task, and it's when you put your final task in that it completes. And then diagramming is one of the big things that they like in the system. So this is a diagram showing all the relationships between the entities in this case. And sometimes when they have a diagram, this one's fairly simple, but you could imagine a diagram with a couple of hundred entities on it, and there's a whole lot of spoke wheels going into 2 people that go out to lots of other ones. Those 2 people visually are people that they might want to have a look at because they seem pretty key. They're involved in lots of ways in this case. So who's it designed for? Well, initially it was designed for a police agency, but it's really for any police or police-like agencies, departments with sensitive data, so an internal affairs people, witness security, or CHIS, which is confidential human information source, in other words, a NARC. They really don't want that information to go outside into the general police systems or general investigation systems. So often these are departments where they want to have a standalone system that's completely separate from their normal IT infrastructure, so that, you know, if they're investigating one of their officers for corruption, there's no risk that he's going to run across that information in their standard systems. Environmental protection agencies use it, so people like the Great Barrier Marine Park Authority, they use Investigator to do all of their investigations for foreign fishing vessels that are fishing within the marine park area, or fishermen that are taking more than their daily allowed catch, and things like that. Border protection agencies, so there's customs agencies or drug enforcement agencies, they like the system, again, because they can keep it separate from their standard systems, which is really important for some of these type of investigations. Oversight agencies, so places like the Corruption and Integrity Commissions for police, these are agencies that aren't part of the police, but they investigate the police or other government servants, and so they like a system that, again, they can keep separate. There's kind of a theme going on here. These people want a system that's very easy to maintain, that they don't have to get their regular IT people involved because the information's often important. And then there's agencies that aren't police, but they have investigation capabilities, like financial institutions for anti-money laundering or fraud, and then sports anti-doping agencies, so all Australian sports athletes and all the UK ones. They're all investigated through, and all of their blood test results and all of their urine samples and stuff, all of that information gets put into the investigation system so that they can keep track of making sure that these people have been tested when they should have been tested, etc. So, what technology are we using? Jade, nothing but Jade. Well, not quite. I wish that was the case, because it would simplify things, but of course, we don't live in a standalone ecosystem anymore. So obviously we use the Jade Smart Thin client for our presentation layer. And you've seen this skin before, and I was talking with someone before. One of the things I didn't mention is you might notice some of these fields have got a very faint little red graphic up in the top left corner. That's our way of indicating mandatory fields to systems, and that's just another skin category. All we've done is put the top left graphic is just 4 red pixels. So we also use third-party controls, like most people, for our diagramming. So the diagram that I showed before, that's a .NET control written by Northwood's software. It's called Go Diagram. They've got a Win32 version, they've got a WPF version, they've got a JavaScript version, and the way you use it is the same across all of those technologies. The API is as identical as they can make it, so if you're swapping and changing between technologies, that's quite useful. And we also integrate to Google Maps, so I put in the location 5 Sir Gill Simpson Drive, and I say, show me that on Google Map, and literally all we've done here is painted a internet control onto the form, and we've sent it the JavaScript to consume the Google API to say, render this diagram, and then I click the show me the satellite view. So once it's up there, you've got all the functionality that Google make available via their public API. Correct. 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 So for the purposes of what we needed to do, we didn't need any extra functionality. For a proof of concept we're doing with some of our other work, we needed a bit more flexibility, so we actually imported the .NET version of the Microsoft Internet Control, and that gave a bit more functionality. But for the purposes of Google, the integration level we needed, we just painted the Internet Control that's in Jade, which is IE, whatever version they happen to be running. I don't believe yet on Windows 10 that it goes to Edge. I think it sticks with IE. Does somebody have another question over that side? Cool. And we use ActiveX automation. So a lot of our reports that we're now writing, a lot of the agencies said, we like the report, but actually what we want to do is get the report and then value add additional information in it. So there might be information that for various reasons they don't want to put in the system, but they need to put it onto the report, or there might be information that's not in the ICM system, it might be in their core policing system. So what we do is, for when you're on an entity, one of those menu items on that extra drop-down menu is to run a word extract report, and then we give them a list of, these are the templates that have been defined for this entity type. So by defined, I mean they create a word template with bookmarks in it, they import it into our system, and then we let them say, this bookmark gets its data from this field in the system, this bookmark gets its data from this field in the system. And if they run that, they get reports completely okay, and we actually launch Word, and it's sitting there with all the information from the Jade database substituted into the relevant bookmark fields on the Word document, and then they can go and do whatever value add they want to do. This one here was a fairly simple example where we're just doing plain text, but if they want images, we'll insert those. If they want it presented in a table, it'll get presented in the table how they want it. So there is obviously a mapping process they have to go through. One of the things ICM has is we don't provide the data fields up front. We provide the standard thing for a person like date of birth, name, surname, etc. All the other information in each installation of ICM is designed and configured using the ICM application for the information they want to capture. So when they want to generate this report, they need to tell us which attribute predefined that we've put out of the box, or which ones they've defined since they installed the application they want to go into which fields on the report. We obviously have to live with other systems, so we are, as John intimated, using both web service provider and web service consumer, SOAP-based currently, although we have got a need in the very near future to provide a REST interface as well. We're using the external database coexistence feature, so we take some feeds from their in-house relational databases and bring it across into our system. And we're using the Jade OGC driver for them when they want to write their own ad hoc reports. We're using the thin client version, and we're using the extensions that were put in whereby as users add new fields onto person, we will update the relational view using some APIs that the Jade plant put out so that when they look at that table in their query tool, they'll see another column in the table, basically, for that data. We're using the .NET exposure. I don't know if any other teams here are using it. So that's where you say which classes and which attributes on those classes you want to be accessible from .NET code, and then Jade will generate a C# project that you then bring into your main project, and then you can access those classes and those properties and those instances as though you were writing J code, or very light J code. But we don't actually in our system expose our real classes, we expose DTO or data transfer object classes, because we don't want to show our main model, we just want to expose what we want to expose. And one of the key things for Investigator is that it's currently used in several different locales, so it's been translated into English and US English, mostly for things like colour, zip code instead of postcode. It's in Thai, it's in Indonesian, it's in Chinese for the People's Republic of China, it's in Swedish, Spanish and non-Cyrillic Serbian. But we don't want to be translators, so we have this concept in our application of presenting the definition of a translatable string, and this one's a parameterized translatable string, so the parts we're highlighting in blue will be stuff that's filled in from the database, and the parts that are highlighted in black are the parts that they can translate. So we present that in a table where the parameterized ones are yellow, and they can alter where they come in the text so that they can make it grammatically correct, and they can translate all the other text around it. And in this example, the person didn't like the way the sentence was written, so they rewrote it still in English, but it could be translated into Chinese. And I've been assured that that doesn't say anything rude. It was translated by one of the members of our team who's a native Chinese speaker. So I was asked to give just a couple of case studies of people that use it. So we've got and these are generic terms because we can't name a lot of our clients, but this is a regional border protection agency. And what they had was a gifting program whereby they weren't going to use it themselves in their host country, but in the neighbouring countries around them, they wanted to provide them with a system that would allow those countries to improve their policing, and thereby, by making them safer, they take care of the problem before it even gets to this country's borders. So it had to be simple to install and maintain. So they wanted to be able to run it on a standalone laptop or set it up for multiple clients, and where they're using it for multiple clients, they wanted them all to be pointing at a single data repository. So Jade SmartThin client into an app server was a good way of doing that. They needed it to have limited training required because some of these areas are countries that aren't necessarily that up with the play technology-wise. They wanted to be able to make changes to the configuration without us having to do coding changes. So our system has a very soft model where they can define their own attributes of person or vehicle or location or cases and case notes, and even what the relationships are between entities in the system. All of that's configurable. Again, they wanted it to be translatable for different locales because this is going into non-English speaking countries, and by helping protect their borders closer to the source of where the criminal activity was happening, it meant that it was cheaper and easier for them than trying to prevent that once it got into their own country. The second agency was a witness protection agency, and as I probably mentioned earlier in the slides, they needed it to be very simple to install and maintain because they weren't going to be using their IT infrastructure people, and they were in a secure off-site building that isn't even named or signed or in any way associated with that main agency. And it must not require any internet connectivity, so any upgrades or any licensing and installation and registration all had to happen by them either typing in or putting in a USB stick that had all of the information on it. They could not download anything from the internet. The system was completely standalone. Obviously that means their Google Maps integration is not going to work for them because the system's got no internet activity. But one of the things about witness protection agencies is that they will never go onto Google Maps and say, where is this address, and put in the address of a safe house, because they're now putting information out into the public domain. Okay, it might take a bit for people to work out who put that address in, but even putting the address of the safe house into a Google search, they won't do it. It's just the way they are. It needed to be easily configurable again, and it needed to be highly secure, and by highly secure, there's no way on earth they wanted user A to ever see information about the witnesses of user B. They wanted no concept of a super user in the system. They didn't want a DBA to be able to open up the table of database data and look at the tables in raw data. So for them, having it in a Jade database without a SQL query stuff all built in was really positive for them. And all activity had to be logged, including what the values were before and after when somebody updates something, including the fact that somebody just viewed an entity, or even to the level they wanted to know if the search that somebody put in would have brought back an entity that they don't have access to if they'd been able to have access to it. Because, for example, if they go on and do a search for a famous person like John Key, you may want to know about that, so they can put alerts in the system saying, tell me if any of the search criteria will or would have returned a person of interest in the system. So that was, again, vitally important to them. And John mentioned before that I might mention something. So one of the things that we had was that diagram that I showed. And we're using a .NET control because it was one of the best ones we could find at the time we were doing this diagramming. But one of the downsides is that every time you access a property or call a method on a .NET control, Jade obviously has no way of knowing what the impact of that is. So every time you do that, your code and your app server sets a property. It has to go to the thin client, tell the control that property has been set, and then it can do whatever needs to be changed on the rendering and then come back again, because Jade doesn't know whether that might cause other events to need to be invoked and stuff. So if Jade's, say, setting a caption on a text box, or a label, or setting the text of a text box, Jade knows what that means in terms of what's going to happen on the thin client, so it can buffer all that information, and only when it reaches something that forces a round trip will it do a round trip back to the app server. So what we had was we had a test diagram that I'd whipped up that had several thousand nodes on the diagram and multiple relationships between the nodes, and that was from a home connection taking over 7 minutes to render the diagram. And that was because it was doing several thousand round trips from the app server to the thin client and back again. So we changed that to say, let's just build up a JSON message that describes the diagram with all the information about the relationships, the entities, what the captions should be for all the nodes and stuff on the diagram, what images we should use. And let's send that one message, and then let's use C# code to read through that JSON and render the diagram all on the client side. So it was a single round trip with a very large JSON payload. And our test diagram, by making that change, had gone from 7 minutes to 32 seconds, which was quite a big improvement, but it still wasn't at the sort of level that we wanted. So we did some profiling, and we found that of that 32 seconds, it was taking 30 seconds to build the JSON string in the Jade code. And the profiling showed that most of that time was spent doing string concatenation. So every time we added to the JSON string, Jade was having to allocate a new buffer in memory, big enough to take the old string plus the new buffer. So using some of my internal knowledge from Jade support days, I knew that by putting that onto an object, which is where it was being concatenated, it means that we were crossing from the interpreter into the JOM to do that concatenation, and we were continually extending in memory. So I changed to using local variables, and that helped. It took about 5 seconds off the time, but it still wasn't good enough. So then I used a bit more knowledge about how Jade strings work, and I started pre-allocating the string to initially a 1K buffer, and once I'd filled up that string, I'd turn it into a 2K buffer, and once I'd make it 4K, and then 8 and 16. So each time I'd reach the full size of that string, I'd double the size of the buffer, and making that change brought the total time to render the diagram from 7 minute starting point down to under 2 seconds for the same diagram. And so our clients, when they got this release, were astounded at how snappy and fast and usable the diagramming became. So I decided we better have at least one slide with Jade code on here. So this was our original Jade code, where we just, for each in the diagram, self.json for diagram equals self.json for diagram, and the next bit of JSON for the next diagram element. And self was an object, so we were crossing the interpreter JOM boundary at that point. So that was nice, simple code to look at. This is the code that runs faster. And I'll just bring it up a bit so you can see it better. So basically what we do is we set up our current offset, which is going to be the first position in the string. We set our buffer size, and then this is where I'm using the internal knowledge. I actually allocate buffer position 1024 to be equal to null, which means the string's still currently null, but it's now 1024 bytes of null rather than 1 byte of null that it started with. Then I go through the diagram elements and I get the next bit of JSON. So those 2 lines of code is the same as what we had before, although it was being used in a concatenation statement. The next thing I need to know is how long is this next part, and that becomes important later on. I say that my buffer wasn't increased this time around in case we increased it last time, and then while the current offset plus the length of the next part is greater than the buffer size, i.e. we need to increase our buffer, I double the buffer size and I set that to true. What I'm not doing at this point is changing the size of the string yet, because the new string that we're going to concatenate in might be 4 times the size of the current string, particularly if it's now a base 64 encoded high-res image of 2 megabytes. So we work out how much bigger we need it to be until that loop's finished, and then at the end, if we set that boolean to true, only then do we set that buffer size position equal to null. And what that does is it extends the string out with a whole lot of nulls, but it's still got the data we had up to that point. And then the key part is this one here, where instead of doing a concatenation statement, I set the value from the current offset for the next diagram length to the next diagram part. What that's doing is just splicing over top of those bits of buffer, the next bit of the string, and then I increment my offset. So basically, if the message I needed to send was 16K, I only reallocate the string 4 times or 5 times, rather than reallocating it 16 times. So even though that's running a whole lot more code, it actually took the time to build the JSON string from 30 seconds down to 59 milliseconds, which was a significant improvement. And then the last part is we actually want to make the JSON string only as long as the real stuff. So we set it to from 1 to the current offset minus 1. So Jade will truncate it down to the actual string size. Otherwise, we'd be sending a huge lot of nulls across in the JSON string. And then we just do a single assignment at the end, which is the only time we've gone out of the interpreter for this code. Well, other than getting the data, but in terms of the concatenation of the string, that's the only time where we're going from the interpreter to the JOM to assign that value. If anyone wants this code, I can share it on the forums. But if you're doing any large amounts of string concatenation in your system and that's becoming a performance issue for you, this will save things. And my last lot of tips was, is your application looking old and tired? I had to do this presentation before I realised I was doing the skin one, so it's just re-emphasising, use the Jade skins, reduce the borders, make the separators more muted, increase your line heights and your white space, and use some more modern fonts. That's it.
The reason why that thing you just showed me, it's a huge improvement in performance configuration in the mix,
Okay, so one of the things I had to do for this was I can't call a method because you hit the JOM at that point. So to get this performance benefit, we have to make sure we don't go near the JOM, and anytime you call a method, you go near the JOM. If we're calling a method, we'd have to pass a parameter across, potentially the self dot. So self is effectively going to be passed across as another copy of self. And yeah, so yes, so initially I tried to put this on a class called String Builder. I don't know why I chose that name, but I did. But it performed worse than the old style plain concatenation because it was doing even more crossing of the interpreter JOM boundary. So yeah, it would be really good to have a way of doing that, but yeah, it's fairly simple code to do. But yes, I had to inline a lot of stuff that was previously method calls in order to get the performance. But I had to do that because 7 minutes was unacceptable, and even 30 seconds was unacceptable to render the diagram. So yeah, sorry, you have to inline it. And this also wouldn't perform if I wasn't using local variables as well. Again, it would be crossing the JOM interpreter boundary. I was surprised at how much quicker it was. I thought I had my code wrong. It took me a while to convince myself I had built exactly the same string because it was so much quicker.